Welcome to the MOOC course on Strategy and Introduction to Game Theory. In this module, we are going to talk about a different form of game. We call it extensive form game. We will shortly learn what do we mean by extensive form game. So far, the game that we have seen are classified as normal form game. We also call them strategic form game. What happens in the strategic form game? We have three pieces of puzzle. One set of decision makers, we call them players. Second, that all the players have certain strategies that they can employ in the strategic interaction, and then based on the different strategy profile, we have different payoffs for the players. What is the rule of the game there? That all the players would move simultaneously. That is the key word. The normal form game allows only simultaneous move from the players. Now, what do we mean by simultaneous form? It does not mean that everyone has to move at the same instance. It only means that when a player takes his action, he is not aware of the actual actions taken by all other players. Okay. So, that is why we call it simultaneous move game. So, even if they are moving at different time, it is like simultaneous because they are not aware of others' action. That is the key word, that players are not aware of others' action, others' actual action. They are aware of the different actions that different players can take, but they are not aware of the actual action taken by the players. But in many instances, we know whenever when a decision maker has to move, he knows the action taken by other players. Let us take an example. We call it entry game, that is entry into market. Let us say a firm is thinking of entering in the market. Now, the firm that is present in the market would see whether other firm has entered or not, and then the firm that is already present in the market would take necessary action. Or a variant of a Cournot game, in which a firm first observes the production decision of the other firm and then decides the quantity it would like to produce. Similarly, in bargaining, when bargaining happens between a buyer and seller, buyer observes the price offered by the seller, then buyer makes a counter offer, and so on. So, they both are aware of the actions taken by other players. So, this game can still be modeled as normal form game, but we will see that it may have some problems. So, we should figure out a different way of representing them. Just to give you a simple recap, what happens in the any strategic decision? The players may move simultaneously or sequentially. Sequentially meaning they move after observing the action taken by other players, and also they may move once or many times. Their interaction may get repeated also, but in normal form game we allow for one, as it is that players are moving only once, and this statement of mine will become clearer little later, probably in the next module, when we differentiate between strategies and actions. How should we represent such interactions? We have figured out a way of representing in normal form game, but here let us look at in general what are the things required to describe a strategic interaction. What do we need to give? List of players participating in strategic interaction. This term was present, this piece of the puzzle was required even for the normal form game. Second, we need to know when does a player get to move in the game, meaning order of the game. Okay? This was not required in the normal form game, as players move simultaneously and once and for all. Third, what are the actions available to the player when he gets to move? It is same here, we are describing the action. Earlier also we were talking about something similar, strategies. So, actions are similar to strategies, but again they are bit different. Next thing required is, it is very important, but I would not emphasize it today. In one module would be dedicated to discuss this particular thing. So, how much does a player know when he gets to move? So, what we are so we are allowing for possibility that normal form game in which player does not know the actual move of the player, or any sequential move game in which player is aware of the action taken by other player, both could be represented, and again then payoffs. You should notice that 1, 3 and 5 were required in a normal form game. What we are adding, in fact this is rich representation, that we are adding number 2 and number 4. So, one can say, if one has to describe the game, it needs in more detail, then it needs much more things described. So, one can say that normal form game is reduced form representation of a strategic interaction. Let us take an example. As I already gave you this, what do we mean by an entry game? So, we can say that there is a market. In market we do not mean, by market we do not mean a marketplace. Market is precisely where buyers and seller come together to exchange a particular good. So, let us say this market is characterized by a monopolist. You can think that this is a market for food business, there is only restaurant in the town, or it can be only TV seller in the town. It does not matter, as long as they are selling one particular good and there is only one seller. We say that market is characterized by a monopolist. So, this firm, we will call this firm as incumbent, as it is already present in the market. Now, the next step is that a rival firm, we will call them entrant, because it is thinking of entering in the market, is contemplating whether to enter in the market or remain out. The incumbent, that is monopolist, can engage in costly advertisement or price cut to fight the rival, or do nothing. We can assume that entrant moves first. Let us say that incumbent is not able to figure out beforehand whether entrant is going to enter or not. Only once entrant enters in the market, monopolist observes it and then takes the action. So, how do we represent such a strategic interaction? First, we have to give the list of the players. There are two players, one is incumbent and second is potential entrant. Potential entrant has two actions available. One, whether to enter in the market or not enter. Enter we will represent in short by E, and not entering will be represented by N. Next, for incumbent we have again two actions available, either to accommodate the entrant, that is A, or fight, that is engage in costly price advertisement or price cut. Okay. What are the payoffs? We do not know the actual payoffs, one will have to do market survey to figure out, but we can say that for entrant the best outcome is that entrant enters and incumbent accommodates. Okay. In that way entrant will get some market share. So, that is good for the entrant. Second best option is for the entrant is that entrant does not enter in the market. Okay. And third is that entrant enters and incumbent fights, because fighting would be costly for both of the firms. Notice one more thing, that if entrant decides not to enter in the market, then game would end, because in that case the incumbent does not need to take any decision whether to accommodate or fight. Okay. How about incumbent? Because incumbent is a monopolist, so most preferred outcome for the incumbent would be that entrant does not enter in the market, so no entry. Second best outcome would be entry from the entrant and incumbent accommodates, and the worst outcome for incumbent would also be that entrant enters and incumbent fights. Notice it is also very well possible that order of the best to worst order of the payoffs would be different, but this is our assumption, which would be true in several market, but which may not be true in the several other market. So this example I am taking very specific payoffs, okay, and of course outcome would depend on those specific payoffs. We cannot assume blindly that in all entry game this would be the order of payoffs. So what we can say, as we do not know, we can give the, this is the, okay. So based on this order we will, because as we have learned already in the other module, that the order is the most important thing, not the actual payoff. So we can simply give it, let us say 3, 2, 1, and here also we can go for the same order 3, 2, 1, but just to illustrate that we do not need to give the exact same number, we just need to maintain the order. So here we are going to give 1, 0 and -1. Okay. So let us come to game tree. And what is game tree? Notice that, remember that in normal form game we were using bimatrix table to describe the game. Bimatrix table contained list of player, it also gave all the actions or strategies that can be employed by players, and also respective payoffs. So similarly, game tree is the nice way of giving all the 5 pieces of puzzle that we had written here. These are the 5 pieces. So let us look at it. Here entrant can either enter or remain out. Earlier I said that not enter, you can use O or N. Earlier I said N, but here I have written O, so sorry about it. So entrant can either enter or remain out of the market. If entrant remain out of the market, then entrant gets 0, as notice that this is the second most preferred outcome for the entrant, and incumbent gets 3. But if entrant enters in the market, then incumbent gets to either fight or accommodate. So these are the 2 things that incumbent can do, and these are the respective payoff that we have written in the earlier slide. So what is a game tree? So game tree is basically a simple and useful way of representing an extensive form game. Basically game tree is a graph which consists of nodes. These are nodes. These orange disks, small disks, they are nodes, and then we also have branches. What are the branches? The line that connects 2 nodes is called a branch. So we have branches. So we have one branch here, another, and these are the 4 branches. Nodes should have, there are 3 different kinds of nodes we talk about. One is initial node. What does it indicate? It indicates the beginning of the game. So here this node is the initial node. Then we have second kind of node. These are called decision nodes, where players get to take decision. So players get to take decision at this node and this node and also this node. Notice that this node is initial node as well as a decision node. An initial node could very well be a decision node, and then we have terminal nodes. Which are the terminal nodes? This one, this one, this one. Terminal nodes indicates the ending of the game, and the also it will be the payoff that the players would get. Notice that on all the decision nodes we have written a name of the player who would get to move at that particular node. Like here in this decision node, entrants get to take action. At this decision node, incumbent gets to take action. This node is not a decision node, so we do not label it with a player name, but this node is a terminal node, so it is labeled using the payoffs. Okay. We will also notice that all 5 pieces. One piece was information. Nodes also relate to information, but that I am keeping for other module. For simple game, we do not need to understand information. Little later we will need to understand the role of information in extensive form game. And branches are labeled with actions, like this branch is labeled with E. What it says that when entrant takes action E, then incumbent gets to move. Okay? So, this branch is labeled with E, that is the action taken by entrant. So, this is the game. Let us say if we want to represent the entry game using normal form game, can we do that? Of course, we can do that. Normal form game has little less structure as it is reduced form. What we need is list of the players that we have. Here we have entrant and here we have incumbent. And then entrant can of course enter in the game or remain out of the game, and incumbent can either fight or accommodate. How can we write the payoffs? Let us look at it. It is very clear that if entrant enters and incumbent fights, then the payoff is -1 and 1. This should be +1, sorry. Similarly, when entrant enters and incumbent accommodates, then the payoffs are 1 and 2 respectively, 1 and 2. But if entrant remains out, then incumbent does not get to move, then what would be the payoff? Notice I have written 0 3 0 3, which is the payoff when entrants remain out. In this case, entrant gets 0 and incumbent gets 3. Same here. Then why I am writing in this column in fight column and accommodate column? Notice that when we are talking about normal form game, then what happens? The assumption is all the players are moving simultaneously. In other words, when a player takes his action, then he does not know the action taken by other players. So, let us say how this game is being played in the normal form game, just for understanding that rather than observing the entrant, whether entrant is entering in the market or not, there are two players, one named entrant, another is incumbent. They are writing on a piece of paper their decision that okay, of course entrant has two actions available, entry or out. So, that is what an entrant can write, and similarly incumbent can write fight or accommodate. Of course, incumbent may not get to fight or accommodate if entrants write out, but the thing is that incumbent does not know what entrant is writing. So, here these payoffs are solely decided by what entrant is doing, not what incumbent is doing. Okay. So, this would be normal form representation. Okay. As we are here, we should also try to figure out what would be the Nash equilibrium, or let us wait, we will talk about it. First, let us get the new concept. How should we solve the extensive form game? Of course, one way to solve is that let us represent that extensive form game in the reduced form, normal form, and get what happens. But we will see that there are certain problems there. What we can do here is that very simple notion that we will look forward and reason back. Notice that entrant and incumbent both are rational player. Not only they are rational player, entrant knows that incumbent is a rational player and incumbent knows that entrant is the rational player. As incumbent is rational player, he sees that if I fight I get -1 and if I accommodate I get 2. 2 is definitely more than -1. So, of course, what would incumbent do? Incumbent would accommodate and would not fight. If game moves to this point, it is rational for incumbent is to accommodate. Of course, before entrant let us say that entrant has not taken either of the action E or O, but he knows, entrant knows that incumbent is a rational player, and given an opportunity to move at this point, incumbent is going to accommodate. So, entrant knows that if he takes the action E, game game would move in this direction and payoff would be 1 for entrant and 2 for incumbent, and if entrant remains out then the payoff would be 0. So, 1 is definitely greater than 0. So, what would entrant do? Because entrant is rational, entrant would move in this direction, and then of course, we have already figured out that incumbent would take action A rather than F. So, what is going to happen in this game? Entrant is going to take action E and incumbent is going to take action A, and the payoff for entrant is going to be 1 and payoff for incumbent is going to be 2. Notice what did we do? We started solving game at this level. Later on we will learn we have a specific name for this structure that we will come to later, but notice what did we use? Rationality and common knowledge. Not only players are rational, they know that the other players are rational. That is the information, that is the input that we took. So, what is happening? First we solved here, then we know we said that entrant knows that if he takes action E, game is moving to in this direction. So, we are looking forward, but we are reasoning back. This is, or in other words, we begin at the end. This is called backward induction technique, and this is very useful in giving solution to most of the extensive form game. Later on we will learn that there are some problems with the backward induction, so we need more elegant solution technique. We will talk about it little later. Now, let us see what happens when we talk about Nash equilibrium. What is the best response if incumbent fights? What is the best response for entrant? Best response for the entrant is to remain out. Okay? And if incumbent accommodates, then the best response is to enter. Similarly, let us look at it from best response of incumbent. If entrant enters, then the best response is accommodate, and if entrant remain out, then the best response would be fight or accommodate both. So, here we get two best responses of best responses. What do we get? Out, comma, fight, and entry, comma, accommodate. Okay? There are two Nash equilibrium. Now, let us say that what happens? Okay, so what we have seen, we have used two different techniques. One is backward induction technique. Backward induction gives us the outcome as enter, comma, accommodate, means potential entrant enters and incumbent accommodates. Second technique is the Nash equilibrium one that we have been using in the normal form game. What do we get? Two different outcomes are possible according to this concept. One is that same as the backward induction, but Nash equilibrium also suggests second possibility that what happens, that the incumbent fights and entrant remains out. Okay? So, these are the two possibilities. In one of the next module, we are going to something called sequential rationality and justify that backward induction outcome recommendation is better than Nash equilibrium recommendation, and we will talk about it in the next module. Thank you.